Hey everyone, I'm Aman Shastri. Hope you are all doing well. Welcome to our first video on this Arduino tutorial series. Arduino is a microcontroller and can be used to control various sensors, lights, motors, anything you want, right? At the heart of every electronic project, be it drones, be it automation, is a microcontroller, and we're going to dive into learning about one of them. Now, coming to the Arduino Uno, that's specifically this module we have here, there are 14 digital pins. That will be these digital pins right over here. Actually, let me get a wire so that I can get pretty accurate. Right? So these are your digital pins from 0 to 14. 0 to 30. There are 14 of them. There are power rails where you can get 5 volts, 3 and 3.3 volts DC. There are even ground rails. Lastly, there are these analog pins from A0 to A5. Right? Through these pins, you can read a varying signals from different sensors. Having said all that, let's go into building a very basic circuit. We're going to turn on an LED using an Arduino. For this, we'll need the most excellent Arduino Uno, a breadboard, an LED, and a resistor of 220 ohm. I'll explain how the breadboard works along the way. Before all of that, we need to install the Arduino IDE, which is basically where we're going to be writing all our code. So let's go to this website, which is www.com arduino/cc/en/software. What we're going to do is we are going to go to this website and download the latest version available, right? Now what I'm going to do, I've installed this Windows application, right, for 8.1 or 10. This is going to install an exe file onto your system, right? So once installed, just run the exe file and that should install the Arduino IDE onto your system. Now I've already installed mine, which is why I'm not going to be clicking the install button, and I'm going to run the application. Once you run your application, you're going to see a screen that looks something like this. So go ahead, we can start a new sketch, right? And we are going to program all our Arduino stuff over here. Before that, let's build our circuit. So let's go right into that. Now how the breadboard works is every column, every numbered column, for instance you can see column 5, column 10, column 15 and so on, all the pins in all of these holes are connected. However, that does not hold true for these two ends of the breadboard over here. These are called power rails. Now every single row in the power rail is connected, and each row is for one terminal. So you can either have the 5 volts or the ground, right? So in the power rails, all of these pins are connected and all of these pins are connected. Similar over here, all of these pins are connected and all of these pins are connected. Now what we are going to do is we are going to get any one of our LEDs. I am going to let's take a red LED just so that it's easily visible. Okay, now obviously the longer lead is going to go to the positive terminal and the short lead is going to go to the negative terminal. Let's stick that right onto here. Now note that the positive and negative terminal are directly not connected as of now. What we are going to do is we are going to drag a 5 volt from the Arduino. Now look at this. This is the 5 volt line DC. Okay, we are going to put a pin right onto that and we are going to stick it right onto there. However, if we do that, the LED is actually going to blow out. An LED cannot handle as much as 5 volts. So what we're going to do is we're going to put a pull down resistor. Now note that there's this bridge and pins on either side of the bridge are not connected. So if I send a signal over here, right, the LED is not going to turn on just yet. So I need to connect it through a resistor, right? Now current is going to flow from the 5 volt pin. We are directly giving it power, right, through the resistor to the LED. Finally, we are going to send that to the negative terminal or the ground, right? So we can go ahead and put in another pin, right, connected to the negative terminal, and finally complete the circuit by attaching it to the ground pin on the Arduino. For this experiment, there is no coding needed because we are directly giving 5 volts, so we can plug it into our USB right here and check it. And if you can see that the LED has turned on. The LED has turned on. There's a faint light. There's a lot of glare, so I cannot completely show it, but if you can see that the LED has turned on. Now how do we actually use one of these digital pens where we can write a 0 or a 1 to the LED? So let's try and do that. Safety first, always disconnect the Arduino and then go into circuitry. So all that's going to change is instead of writing a 5 volt directly, we are going to connect it to any one digital pin, anything of your choice. Anything from 0 through 13 except 0 and 1. I'll tell you why in a second. Let's connect it to pin 7. And actually that just finishes the circuit. Now let's go into the coding part, right? What we are going to do is declare our variables up first. Let me give you a basic introduction of the Arduino IDE before all of that, right? We code the Arduino in C++ syntax. So anyone who's familiar with C++ should be highly easily able to do this. Now this is our coding area. We have two components, two pre-built functions if you will, a void setup and a void loop. Like the name suggests, in the void setup we are going to set up all our pins. We are going to tell the Arduino which pins we are going to write to, or which pins we are going to give a voltage to, and which pins we are going to read from, okay, which pins we are going to take input from. We also start something called as a serial monitor sometimes, right, to just print the values. It's kind of like doing a print statement in Python, right, onto the terminal. And in the void loop, what we're going to do is we're going to put all the code which we want to write continuously. So if you want to write a voltage to a pin continuously, we put that in the void loop. And outside the void setup or void loop, we declare all our variables. So let's go into doing that. First of all, we start by declaring an integer. Let's call it light pin, right? It's always better to have descriptive names for the variables which are not too long. So light pin. Which pin have we connected our LED to? We have connected it to pin 7. At least I have connected it to pin 7. You can mention whatever pin you have connected the Arduino to, the LED. I have connected to pin 7, so int light pin equals 7. And that's about it. That's the only variable we need to declare. Now in the void setup, what we need to do is we need to tell what type of pin is pin 7. Are we reading values from the pin or are we writing values to the pin? In this case, we are going to be writing a value to the pin. We are going to say, hey, turn on this LED when we send a signal to pin 7. So what we need to do is set our pin mode, right, which is going to again specify if it's an input or an output. We are going to mention what pin we are referring to, light underscore pin, and in this case it's an output, which means we are writing to the pin. And that's it. That finishes our void setup. All we're going to tell the Arduino is that, hey, this pin, light pin, pin 7 is an output. So you're going to write to that pin whenever we refer to it. Now in our void loop, what we're going to do is we are going to continuously write a voltage to it. In the Arduino digital pins, a voltage of 5 volts is provided, and since we are putting the current through a 220 ohm resistor, right, the potential difference will drop down a little, so the LED should be able to handle it. What we are going to do is we are going to say digital write, note the capitalization, and if you see that the keywords such as pin mode, digital write turn a nice orange color, that means the Arduino IDE is happy with your code. It knows that your code is right. So anyways, moving on. Digital write means we're going to write to a certain pin. What pin are we going to write to? Again, light pin. What value are we going to write? Are we writing a 0 volt or a 1? Or a 0 or a 1, that's it. So 0 volts or 5 volts we can provide. A 5 volt will be 1. So all we need to do is say high. That means we're giving complete 5 volts through pin 7. Okay? And that is it. That's all we got to do. Let's plug in the Arduino and upload the code. Right? There's this little upload button over here. So let's test that out. Quickly save the file first. Right? You can save it in any name you want. And as you can see, it's compiling and uploading the sketch. Takes a while. This thing is grumpy today. Taking a while too. Yeah, there we go. Ooh. Can open device. Okay, it seems that it did not find our Arduino because I've attached it to the wrong COM port. Well, what we can do is we can go to tools. I'm not able to show it over here, but all you got to do is go to the tools option on the menu bar and then go to the port and select the COM port to which you have attached the Arduino to. It should ideally detect it as an Arduino in the port. So anyways, we got that set. Now we can upload it again. And there again seems to be a problem. Why is it not finding the device? It's expired. Oops, I chose the wrong port. Alright, last time. Let's do this. Fingers crossed. And we're done. Alright, it is uploaded, and if you can see, the LED has again turned on. We're writing a signal through pin 7, and that's causing the LED to turn on. That's all well and good. Yay, our first sketch. That's so cool. Alright, now let's step up the game. What if we want to control when the LED turns on and when it turns off? So let's say we want to turn the LED on for 1 second, and yeah, stay there for 1 second and then turn it off. Turn it on for 1 second, turn it off for 1 second. So let's do that. The circuit stays the same, and we're going to use the same code that we resumed with. All we got to do now is say introduce a delay of, let's say, 1000 milliseconds. Now what a delay does is it just puts a halt on the code. It just says, hey, wait. And how much time are we going to wait for? 1000 milliseconds. That's just 1 second. Now note that whatever time you're going to give here, it has to be in milliseconds, because the Arduino is highly precise in making time measurements, so it's always better to give it in milliseconds, the time. Right. Anyway, so after we write the after we write a high value to pin 7, we wait for a second, and now what are we going to do? We need to turn the LED off. So we do a digital write. Again, we're using the light pin, and this time we're writing a 0 to it. So we need to say low. That's it. Digital write light pin low. We write a 0 volt to it. So that turns the LED off. What do we need to do now? We need to wait again for a second. And now this code is just going to repeat again. What it's going to do is it's going to write a high value, delay for 1 second, and then turn off the LED, right? Write a 0 volt to pin 7 and again wait for a second. Right? So let's go ahead and upload that. And alright, here we are. Now if you can see, the LED is constantly turning on, turning off. It's waiting for exactly a second. On, off, right? So that's cool. Now we can mess around with these numbers, right? If you want to make the LED blink, if you will, faster, right? We can just decrease the duration for which we're waiting. We can make it 500 milliseconds. That's just half a second. 500, right? Turn the LED on for half a second, wait for half a second, turn off the LED, wait another half second. Loading, and here we go. Now look, the LED is turning on twice as fast as it was before, right? On, off, every half a second. Alright, so that wraps up our session for today. That was an introduction to the most excellent Arduino Uno module. I hope you enjoyed it. I hope you have as much fun with the Arduino as I have done. Right? And I will see you next time. Thank you.